Hi everybody. Today I am going to show you how to do structural analysis for this small building structure. It is a building frame. Our target is to determine approximately the reactions at the base of the column of this frame. And to do this, we will use portal method of analysis. Because it is approximate reactions. So what is portal method of analysis? Let's see. Here it's written the portal method for analyzing fixed supported building frames. It requires these three assumptions. First assumptions, a hinge is placed at the center of each girder since this is assumed to be a point of zero moment. Second assumption, a hinge is placed at the center of each column since this is assumed to be a point of zero moment also. Third assumption, at a given floor level, the shear at the interior column hinges is twice that at exterior column hinges, since the frame is considered to be a superposition of portals. To understand these three assumptions, let's compare it with the frames. This one. First assumption says in the center of the girder, we have to assume hinges. So like this, three hinges. Again, second assumptions, center of the columns, we have to assume hinges like this. Third assumptions, it says shear force at the interior column hinges will be double of what is at the hinges of outside column. That is why here it is V. At the middle of this column hinge it is V. This is outside column. Inner column it will be twice. This is also inner column, so twice of this value. And this is outside, so it is V. So this is the third assumptions. So to do this analysis, let's start from scratch. Click on 2D. Now we are ready to start. So what we will do? Click on geometry axis definitions. Now let's see what is the dimensions in our building frame. Look at, this is the frame we are going to do analysis, right? This one. This one. So what we will do here, look at along x-axis 8 and 8, along z-axis 6 and 5. So let's do that. Here twice to get 8. Add it. So we got twice 8 and 8. For vertical z-axis, say we change here, it is ABC, and here put say 6. Add it, then put 5. Add it, so we are done. Now apply, close it. Perfect. Now we have to put the bars. Let's do that. Click on these bars and start from here, but make sure there is a tick on drag. Why? We can do it continuously. Look at. Done. Now remove drag and you start from here. Again click here and click. Click here and here. Again start, then end. So we are done. Now we have to provide the supports. So let's see. Click on support. Take fixed support here and here and here. So supports are done. Close it. Now we have to apply these horizontal loads. This is actually applied at nodes. So we have to do that. So what to do? First, our task is to take one load types at least. Say we are taking dead load. Then go for putting the loads. So it will working at the nodes. So we have to click on nodes and here nodal force. This is 20. Already we have 20. As we have seen 20 and 30. So 20 will be working along x-axis, so it will be positive sign. So add this, click here, it is done. Again take nodes, change it to 30, add this, click on here. So we got the loads. So we are done. Now we can check the value for this 20 and 30. As well we can see the section shapes as this. Also we can put the dimensions. How to do that? Say here and here it is 8 meter. Look at 8 meter. So we got 8 meter. Again here and here it is 8 meter. So we got 8 meter. Now bring this here. These and this. It will be say 5 meters, and from here to here it will be say 6 meter. So we are done. Now it is perfect. Looks exactly like this. Now our task is to do analysis. How to do that? Click on calculations. It is done. Now we need to see what is the results for reactions. Reactions means we need Fx, horizontal force at supports, and Fz, vertical force. We need diagram for linear supports. We need descriptions as well. We have to click on parameters, click on text, then it will appear. So we got the support reactions. I mean, what are those support reactions? If we compare our results, say here 10.39, 15.55, what is the value here? Fz means here Ax, vertical Ax, downward because it is negative. but here it is showing 15.625, but I got 10.39. Horizontally it is 12.5, I got 15.55. So it means my result is not matching with this. I checked only one place, it is not matching. As well, this will not match also, because here basically it is done by software and it is not portal method analysis, because software normally they use stiffness method. I mean finite element methods, they use that through stiffness method, and they do it by matrix analysis in their programmings. But our target is to use getting approximate reactions by portal method analysis. What is that? We have to provide here hinges, here hinges, here hinge, here hinge. Then also we have to check this shear and this shear must be double of this. Then only it will satisfy the portal methods. So let's do that. So I am removing all these loads as well the reactions. So all gone. Now our target is to make the, let's click on node to see the nodes, because first we will create node at the center of the girder and center of the column. So how to create those nodes? Let's select all this beam and column. We go for edit, dividing. So dividing into n parts means 2 parts. So we'll get the center. And remove this stick, execute. See, it is done. Before there was no node number at the center, now we got the node numbers. Now our next task is to provide here all these nodes, the hinges. How to do that? Geometry, go for releases and paint one end. I will use this. So pinned one end, it means I have to say put pins here and here. Now it is more clear. I remove the sections. Now it's more clear. So here also I have to provide that pin at one end. So it is done. Here also it is. So here and here, so everything done. I think everywhere done. Here, here, so I think done. because here, yeah. So this girder is done. This column 2 places, here column 2 places, here column. So we are done in every points. I mean column center, girder center, hinges are provided. So we can close it. Now another important points. First and second assumption is done. But what about the third assumptions? Third assumption is says here third assumptions here where it is. Yes, I can show it here. It is more clear here. Explanation is more clear on this place. Yes, here it is more clear. Suppose if I consider here V in the inner column, I have to consider 2V. So in the same way, here if I consider here at this center it is V, so here will be 2V and here will be V. So V plus 2V plus V. So 4V. 4V equal to here I applied load say 20. Here I applied load 20. So what I'll do, 20 divided by 4V, it means V equal to 5. So what I'll do now, I will change this. Like here I have to apply 5, here 10, here 5. Again here 7.5, here 15, here 7.5. So it will satisfy the third assumptions. So let's do that. So how I'll change this? Go loads, load table. This one you can change it. Say here it is say 20. Make it 5. Here it is 30. Make it 7.5. So we are done. Look at here automatically changed 5 and 7.5. Now what I'll do, I am removing these nodes. I will apply loads here. Say at nodes, here I will apply 10. So add it, apply here 10. It is done. Again go here, put here 5, add it and apply here. So it is done. Now for this part here I will do 15. Click here, make it 15. Add it, click here. So 15. Again here I need 7.5. So make it say 7.5. 7.5. So add it, click here. So I am done with loads 5, 10, 5 because inner column this hinge position action will be double of this shear. That is why I just put the loads like that. Now if I go for analysis, let's see. So what I'll do now, I will check again these results for the reactions. So here I click on reactions, here fx, fz and diagram descriptions. Here I am taking parameter for the text. So apply. Now we can compare the results. What is that? 12.41, 12.16. Let's see that. This is our structure. So we are going down to see. It is saying here it is 12.41, but here 12.5 kilonewtons. This, not this one. Sorry, not this one. This one. That is why I got very different value. Yes, this one, A, because this point is A. So A means A 12.5, but I got 12.41. Very close, but not exact. As well, vertical force I got 15.625. 15.625, but here it is 12.16. As well, if you compare the second point B, because here if we look at diagram, you will see this is A, B and C. So let's compare B, because they put value for A and B. So here A and B. So where is B? This is B. This is B here. So what is the value for that? B downward, it is 0, and here 25. I mean this one, Bx 25, By 0. So what is our value here? Here it is what? Fz 5.49 and Fx 25. So this is matching 25, and Z is, I mean vertically By, it is 5.49, but here it is showing 0. It means still there is difference. Why there is difference? That's, I know that. Why difference is there. Now I'll do one thing. Let's go to the loads. Load table. What we will do here, we will remove the self weight. I remove the self weight. Now here what I will do, I will go for calculations again. It is done. Now astonishing thing happens. Exact value we got if we compare these two reactions. How it is? You see here, I brought here two values. Look at AY, 15.62. I got 15.62. What about FX? Look at AX, 12.5. Exact value. Again for point B. What is for BY? It is 0. Look at FZ equal to 0. What about BX? It is 25. Here it is 25. So we got now exact reactions. What is calculated here? manually. Look at now, perfect. We got the exact reactions. Now here there is a bending moment diagram for 50, 50, 50, 50. This is actually for, I think, in the middle, maybe DMENF. Though it is not asked, already we got the reaction perfect. Let's see DMENF, this diagram, how it looks. Here, okay. So let's see that we can bring the moment diagram. Already we know what is they asked. Actually, they asked only the reactions. Let's check the moment diagram here. Let's see it is coming the figure or not. Parameters, fence, okay. Oh yeah, we got it. Let's see the diagram. You can see this moment in this middle girder. I mean this first floor girder. You can see here moment, it is 50. So if this moment is 50, so here of course it is 50, because everywhere values are not there, because column value is there, this column value are there, but for the girder here value is given 50, so we will consider this also will be 50 because this is center, and here it is 0 because it is hinge. Here also it is hinge. So this 50, this 50, this will be 50, this will be also 50 according to this value. So let's compare what they say about. Look at 50, 50, 50. So we got 50 also. Perfect. So we got exact value. What is done here using portal method analysis, and in software I also made the frame, I mean making hinges in the girder as well as in the middle of the column, as well I changed the loading system to satisfy the third assumptions. So I think that's all for this structure.